And so it is. So welcome to the Build Classes and Objects Assessment Review. So we have a couple tasks in front of us here. We've got an app RB file in this README, and it's asking us to build a Ruby class for a building. So the way that I want to do this is this is called a whip around. I'm going to ask each person for one step. If you don't know what the step is, completely fine. We'll figure it out together. But we're all going to figure out how to get through this assessment together. So to start us off, let's make that app.rb file. So it's the same thing we would have if we had cloned this down. And Adrian, can you give me a first step to get started on this?
No, I don't think so.
Okay. So let's take a look at this first line here. Build a Ruby class for a building. So like just brain dump, any ideas of what I could do to build a Ruby class for a building?
But class, building, and
Perfect. I love it. Building. And all right, seems like a pretty good place to get started. Now we can do this all just in this one file. I'd recommend you get in the habit of breaking these out into separate files. So I'm going to make a building RB file. And we're just going to move that class into there. And then we're going to import it. Okay, so we're off to the races. Bob, can you give me a next step?
So you have to define the initialize with the name, address, number of floors, and number of tenants. And
Beautiful.
I would set number of floors to 0 and number of tenants to 0, just so there's a what's the word I'm looking for? So there's a thing there.
I like it. So initialize is going to have a name, an address, number of floors, and we can initialize that to 0.
Default, that's the word I was looking for.
Yes. Number of tenants equals 0 as well. Cool. So doing pretty good so far. Lynn, give me a next step.
The addresses should be readable. So you want to do an adder reader.
Okay. Cool, very nice. Kyle, give me another step. You gotta unmute.
Sorry. We can do an ATTR writer for the stuff we need to have written.
Okay, what's that?
Stuff we need to have written should be the number of, or not the number of floors, the should be the number of tenants and the name.
Okay, so those say name and number of tenants should be writable. They should also be readable though. So I could do adder writer. I could probably also just throw these into adder reader also. I think that technically works. So I've got a more efficient way to do that, don't I, Kyle? What is it?
Is it ATTR attribute, is it called?
Oh, almost. ATTR ACK
Accessor.
Accessor. There we go. So I do number of tenants and name for that. And now we can blow all that out. Okay, very nice. Logan, give me another step.
So in the initialize, we need to go through and take all of our variables and set them as, I believe, attributes with the @
Mm-hmm. Very nice. Okay, it is so. Will, give me another step.
We need to create an add at all variable to collect all of the buildings that we make.
Cool. Anything else I need to do with that add at all?
Define a self.all method.
We definitely do, but
Oh, I'm sorry. Set it to equal to empty array.
exactly. See, the text editor is mad at me. I didn't do it. Okay, very nice. And then you also were suggesting we have a self.all that just poops it back. I like that. Cool. Matt, give me another step.
Okay. You need to with the double ampersand all. I think is that class variable. Is that right? Is that what it's called?
The class variable. That's a class variable right there.
Oh, class variable. We have to shovel all those the self. It would be shovel self. But
Shovel self where?
into the double ampersand all, the class variable all, right? Okay.
Just like that. Cool. Very nice. Very nice. Making good progress so far. So we can initialize the name, address, number of floors, and number of tenants. We can read and write the name and number of tenants. The address is readable. The number of floors should not be readable or writable. It's not. The class should keep track of all buildings that are created. We're doing pretty good so far. So Bryce, give me another step.
So to find the average number of tenants, we need to make a class method. So I would do def self.tenant average.
And then, come on, man. Okay, and then what happens in the tenant average?
So in there, I would figure out the total number of tenants that we have. So I would do a total tenants equals at all reduce.
Ah, at all reduce. Reduce is the scary one.
And so then in the parentheses, I'd do a 0 because we're doing a number.
Okay.
And then I would do it on one line because it's not going to be too long. So curly braces. In the pipes, a tenant count, and then after that is going to be building. And then I'm just going to do tenant count plus building dot tenant count. And then on the next line, I'd just do total tenants divided by at all dot length.
Not bloody bad. So at this point, we have some real logic here. So we should probably make sure that this works the way that we think it does. So I'm going to say, Ben, help me figure out how I could test whether or not this tenant average function works.
You don't want me to just fix it?
No, I want to find out
So
what's
you
happening
put,
right now.
so let's see, you want to put, oh, you'd have to make an object to test it, yeah.
Yep, so where am I going to do that?
So go to your other file and do building dot, or house gets building dot new. And let's see, what does it need? Name, address.
Address, number of floors, number of tenants.
So you can just put in, just to make it simple, house, Kyle's house, there you go. Address 123 Valley Road. Oh, there you go. And the other stuff you can leave blank because it has defaults. We're not testing
defaults
that.
and no floors and no tenants.
Oh yeah, so you do need tenants. Make it 5 tenants. Floors you don't really need because it's not readable or writable, right?
Ooh, doesn't mean it doesn't get used. It's not readable or writable outside of the class. Within the
Okay.
class, we can absolutely do that. And if we're looking ahead on here, we're going to need to get the average number of tenants per floor.
Yeah, that's the only one I couldn't figure out.
All right,
All right, so let's make floors 3 and tenants 5.
beautiful.
And then do we do a pry, right?
Yeah, we should probably get a pry in here. I like that.
Yeah. And then binding.pry at the bottom. Run the program.
Oops, that's right. I didn't like that.
And
Okay, now
you
what?
do how and you do house dot what was the method called? Tenant average.
Oh, I'm seeing I read the problem wrong, and I was doing the average number of tenants across all buildings.
Was that wrong, or was that exactly what it was asking for? So Ben, what do I have to? How do I have to adjust that?
Well, let's see. Can you go
I
back
don't
to
want the
the
average number of tenants in one building. That doesn't make any sense.
oh right. So you need more built. You need to make new ones. Make another.
Sure. Okay. What am I putting here?
Apartment equals building dot new. Ben's apartment. 321 Boulder Boulevard. One and one.
Cool. All right. So let's give it a shot. Now what do I do?
You do add at all. Dot tenant average, but that's not right.
So add at all is owned by the class. I'm
Yeah,
not
that's
in the
not right.
class right now. I'm in my program. My program is using these classes and objects.
All right.
So Austin, why don't we give Ben a hand?
Do you call the tenant average
Mhm.
method?
Yep. How? It's not house.tenant average. It's not apartment.tenant average.
Self.tenant? No.
No, probably not that either.
Building.tenant average?
Ooh, building.tenant average. Undefined method, tenant count for building.
Yeah, in the loop, it's building dot tenant count instead of building dot number of tenants.
Oh, I had different variables in mind. Sorry.
Fair. All right. So then we try that again. Weird. And that's exactly what it is, right? We got a 3 and a 1. Average of those is 3. Sick. Okay, let's like muse on that for just a moment. So we made 2 new buildings. Those are new instances of this. Each of those instances was shoveled into this add at all array so that we could call building dot tenant average and work with all of the buildings that we've made so far. We reduced those down and then divided them by all of them. So one comment on this, the length is what it would be in almost any language. Ruby has another alias for length that I think makes more sense in things like this. Call it count. It's the exact same thing. It's just another name for it, but it makes more sense in this circumstance. And this is one of the selling points of Ruby, is that Ruby has a lot of these kinds of things. And when we're talking about being expressive with our code, that's what we mean. Because the length of that array, that's not what we semantically care about. That's not the meaning of this average. We're really taking a count. So that can help like grease the wheels in your brain a little bit sometimes. Also, if I'm looking at this is 105 columns long right now. That's probably a good candidate for something that might be better off as a block. There we go. Now our longest line is 63 columns. That's a little bit easier to read.
Is it bad practice to always do end?
What was that?
Is it bad practice to always do end?
It's unnecessarily constraining yourself. So the convention in Ruby land is to always use do end if it's going to be multiple lines, and always use curly brackets if it's going to be one line. So we have some one-liners that are real damn short and don't warrant being two lines. So I'd say if you can get it under 80 characters, that's probably a good way to do that. Otherwise, that one just gets too long. 109 characters, yeah. So we split that onto 2 lines. Other questions so far about how that class method worked, anything like that?
Can we just walk through reduce?
Mm-hmm. Absolutely. Austin, would you be so kind as to walk us through what's happening in these 3 lines?
All right, so total tenants, we're assigning that to all of these, and we're reducing it down to 0.
Ooh, not reducing it down to 0. What's the 0 doing there?
I'm not sure.
Cool. Let's spend some time with this, because reduce is the hardest one of these applicatives, but it's not as complicated as you're probably making it in your head.
The 0 is the initial value, right?
Yes, it is. So let's draw all this out. Okay, so I've got total tenants equals add at all reduce 0 do tenant count.
So we're returning a single collection that starts with 0.
Correct.
And we're putting all the counts from each building together.
Mm-hmm. Oh, driving me crazy. All right, whatever. I don't know why I can't delete those. So tenant count and building. And then in between, We have tenant count plus building dot number of tenants. Okay, so there's our reduce code right there. So as we just discussed, this part right there is the initial value. We're trying to reduce takes a collection of things and turns it into one thing. Now the confusing part of this, and this is really the only confusing part of reduce, like really, is that one thing can also be one collection. You could reduce something into an array or a hash or something like that. But we say that this thing that we do with the parentheses here is the initial value. So it also ends up being the first value of tenant count. That becomes that on the first iteration. That's important. Say that that's 11. And then the second one works a lot like every other enumerable that you've done. Where if I have people and I select through it, well then I have person on each block. Okay, well that's this thing here. So we've got add all, which is all of our buildings, and so that's a building. We'll say that starts out as Kyle's house. Then we say, okay, tenant count. I want to return tenant count plus the number of tenants in the building. So there was 5 in my building, and this was 0 because we initialized it to 0. So we're returning 5 out of this block. In the second iteration through this, now tenant count is 5, and then where the building is the apartment. And so now we want whatever the tenant count is, which is 5 right now, plus however many people are in the apartment, which is 1. So 6 comes back from this. And since that's the last thing in add all, total tenants ends up equaling 6. Then we said there was 2 buildings, so 6 divided by 2 is 3, and that's what we got. That's how a reduce works. What questions do you have?
So I've been trying to use this to like accumulate a hash, and I'm doing something wrong. I don't know. So every time if your return value is a hash, it will return, and then the next time it comes in, it'll add it with a comma, right? So then every hash you're adding into the bigger hash is separated by a comma?
Not quite. So let's say I had something like, can you give me an example of where you were reducing something into a hash?
So the one I was trying to do, it was like the reorganizing programming languages one.
Okay.
So it has, I mean, and we can maybe do this a different time because it's not really, I don't know, it's kind of long. But if you want me to, I'll go into it.
I don't want to do the entire thing, but let's get started and we'll see how we could work with something that isn't just a number.
Okay, so it's like, it's a hash, and then the first key was OO, so I guess object-oriented languages, which pointed to a hash of like Ruby, which pointed to a hash that said type is interpreted. And then there was like JavaScript type interpreted, I think, and then some. So there were a few of those.
Something like this?
Yeah.
Okay. So we've got languages. So if I want to reduce let's see, be a good place to start. Say, let's reduce the OO thing. So I could say languages at OO dot reduce, and I want to reduce this into some other hash. So we saw an example of this yesterday. When you're reducing a hash instead of an array, so we have that new hash, but we don't have one value here. We actually have two. And so the way that we do that is with parentheses. So the first thing is going to be like the language name. And the second thing is going to be like language details. So if I wanted to like essentially just flip this around so that I'm getting something more like I don't know, something like that. Then what you do is you take this new hash and you want to look up whatever key you're going to have on here, which in like this case is, I think it's interpreted. We want to make that the key on this. So that's going to be language details and whatever the value of its type is. I can do that in more than one step too. You can say language type equals language details type, and then this just becomes come on now. And then I can set that equal to something else. So I might say, all right, well, that's equal to a hash. Interpreted is equal to the language name, or shoot, maybe it's even like language type, language name equals rocks. And then the trick on it is then we need to do our implicit return for whatever the new hash is, because we added it to that. So then the next time around, new hash is the hash with these changes that we've made, but we have the next language name and the next language details. You do it something like that.
Okay.
Cool. Back on track. More questions about this reduce? Austin, let's give this another shot. Can you tell me what's happening in this in these 4 lines of code?
All right, so the total tenants is equal to all of the building's tenant count. It starts at 0, and then we're adding the number of tenants we're accessing from up there, and we're putting those together, and then each time it goes through, and then we divide it by the total number of them.
Yes, that's it. So the big idea in this is this initial value becomes the initial value of tenant count, and then in each loop, tenant count updates with whatever returns out of that block. That's it.
Awesome.
Okay, cool. So we got a tenant average now. Next thing.
Hey, Kyle.
Yep.
Instead of add@all, could we use building.all?
How about we could? I wouldn't recommend doing it, but let's see if it works. Why not? Cool. So if this works, then I should be able to run this app and call the tenant average. Yeah, that works.
But you said not, you recommend the other way?
I'd recommend it the other way. Because what we're doing in these two things is we're reaching outside of the class to like access them through their public interface. We don't need to do that. We have the internal representation.
Okay.
And the whole point of doing that is so that we can access it internally.
Thank you.
Building off
Kyle?
of that.
Yeah.
Go ahead.
Oh, on line 21 then, like where it says tenant count plus building dot number of tenants. So that building, could that be, does that have to be building or can that be all?
So this one,
I guess,
it's a placeholder variable for whatever the current building we're.
oh, okay, I got it. Got it. Thank you.
We could go far, we call it whatever we want. But yeah, it's the placeholder for first time around, it's house, second time around, it's apartment, because those are the two members
Okay.
at all array.
Got it. That clicked. Thank you.
What else?
Instead of using add@all, since it's a class method, are you able to just use all?
That would work. That's the same thing as doing building.all, where you're accessing it through like the external one. Now that said, I think it works. Let's give it a shot. Yeah, totally works.
So it works, it's just not preferred, just like.
Yeah,
building.
I wouldn't recommend it for the exact same reason. So when we do add@all, we're saying, hey, this variable I have access to, let me use it. When we do it that way, we're saying, hey, call this method that just gives me that.
Okay.
So we're just adding an extra step to it.
A little bit redundant in there.
Exactly.
Gotcha.
Also, it'll work fine for things like this where all we're doing is reading it. Give me this array so that I can loop through it. Give me the count of the things. But it wouldn't work for something like this because we can't shovel something into a method. So better stay consistent. Great questions. What else?
Would calling self.all there instead of the add@all do the same thing in terms of like going back and referencing the method?
Yeah. So we should be able to do that. Still works. And that works because what's our one rule for self?
What it refers to depends on whether you're in a class or an instance method.
Specifically, if you're in an instance method. If you're in an instance method, it refers to the instance. Everywhere else, it's the class, including as part of a method definition inside of a class method like this. all of those refer to the class. Inside of an instance method like this, it refers to the instance. That's how it works in most object-oriented languages. There's an equivalent idea in JavaScript called this, which has 9 different things it can be based on the context it's being used in. So be grateful for this. Self is a lot more straightforward.
Kyle, the other day you mentioned that accessor can be finicky. Can you explain that a little more?
Yeah. So in this case, I just told you to make this readable or writable. But let's say you're proving this out on your own. My recommendation to you was to start out as a reader. Because if you, for very legitimate reasons, want to write to that variable, it's going to throw an error and go, yo, you can't write to this. It's read only. And you go, okay, cool. I'll just make it an accessor. Now, if that happens the other way, where you are not supposed to write to something and you accidentally do it, you won't get a warning. So in programming, this idea, I think, is called the principle of least access. You want to tighten things up as much as possible. Make them throw the errors so that you can always make something more permissive, and you can do that very gradually and use the errors to even help guide you on that. You can't do it the other way around. You can't make everything as permissive as possible and then gradually lock that down, because you don't have any feedback loop on that. It's not going to give you any errors.
All right, that makes sense. Thank you.
Cool. What else? Let's keep crashing forward. So we've got the average number of tenants in the building, a placard method that returns the name and the address of the building. Chris Banta, can you help me out with this?
Let's see. We would start by defining the method placard.
Love it.
And we're going to have to take an argument with it, aren't we?
Maybe. What makes you think that?
I was just thinking because it was an instance method.
Okay, it is an instance method. Instance methods don't have to have arguments. But look at what we're doing here. It's returning the name and the address of the building. So for an instance, where did we get the name and the address of the building?
Drawing a blank.
Okay, so take a look up at the top of the initialize. So when we made an instance of the building, we gave it a name and an address up here. It holds on to that. So over here, when I say it's Kyle's house and 123 Denver Avenue, House knows that. House has a name and an address. I can do house.name and house.address, and it keeps track of those for me. Inside of the instance, I can access those anywhere with @name and @address. So for example, the first time, for that first object, that's going to be Kyle's house. Second time around, that's going to be Ben's apartment. So Chris, knowing that I can access those two values with those instance variables, how am I going to make a method that returns the name and the address of the building.
I'm at a loss how you're going to get which building you're talking about.
So this is like the mental connection that we need to make with instances. Since this is an instance method, it means I'm calling it on a specific instance. So when I make house, I call house.placard. I don't call building.placard. I'm always calling that method on a specific instance that has a name and an address already.
Okay.
So that's how it got those. Can you think of how I could return those together in like one string?
Oh, string interpolation.
Yeah, awesome. How do I do string interpolation?
Oh, is it the number sign curly bracket?
That is exactly what it is. What does it need to be inside of? Strings are pretty loosey-goosey in Ruby, except for this very specific thing.
Oh, does it need to be in quotes?
It needs to be in double quotes in particular. Single quotes, you can't interpolate strings. But, all right, so I'm in double quotes. I've got the pound sign and the curly brackets. So what do I do?
Oh, you just put in the name.
Mm-hmm. And?
Do the same thing with the address.
Love it. So now, when I run this app, cool, house.placard gives me that. Apartment.placard gives me that. Because they're instance methods. House is an instance. Apartment is an instance. It's keeping track of its state. Its state is its name, its address, number of floors, all that kind of stuff. And this behavior, the placard method, is reading out that state and just printing it out to the screen, or returning it, I guess. Ask me some questions about that.
If we wanted a placard with all of the buildings / apartments,
Ooh.
all of the buildings.
How would I do that?
Would this be a dot map situation?
Yeah, I would say so, actually. Because if we have two buildings, I want two placards. But it's going to be two objects that I want to turn into two strings. Perfect instance for a map. How do I do it? This is open for anyone.
Start out by making a class method.
Cool. How do I do that?
Self.placard, probably.
Yeah. I can call it the same thing as the instance method because the instance method doesn't exist on the class and the class method doesn't exist on the instance. They point to two different things. Okay, I've got self.placard. We've established that we need to map through something. So what do I do?
Could you do add at all.app?
Yep.
Do and then, I mean, in the block you could put, would placard be?
So what's each individual?
Or tenants.
Here?
Or you see, not tenant.
Plural singular. Plural singular. What's the singular?
Buildings.
Buildings is the
building
plural.
singular.
Building is the singular.
Yep.
Okay, so what do I need to do to transform this? The building.
Call the buildings name and address. Can Can you call the buildings placard
Yeah.
actually? Can you call the buildings placard since we already have that?
You're goddamn right I can. How wild is that? Because this is an instance. I can call an instance method on an instance. I'm going to call this placards. Let's see if it works. Building.placards. Well, what do you know? There they are. Questions about that? Instance method applies to a single building. Class method applies to every building. I can call the instance method here because building is an instance. Cool. All right, last one here. Andrew, get me started on, I have a building that has a method that returns the average number of 10s to 4. Get me started.
Okay. So we'll make an instance method.
Okay. How do I do that?
Def tenants per floor, or maybe average tenants per floor.
I like it. Average tenants per floor. Then what?
Take number of tenants. Oh, hold on.
Mm-hmm.
Number of tenants divided by. Wait, what is that for? Average number of tenants per floor. Yeah, divided by number of floors.
Cool. So if I call that on apartment, I should see 1. If I call it on house, that should, I think that's also going to be 1. All right, let's see. Average number of tenants per floor. All right. House dot average number of tenants per floor, 1. Apartment dot average number of tenants per floor, 1. All right. So why didn't it give me like 1 point whatever the fuck?
An integer, not a float.
Yep. Because if you divide 2 integers, you get an integer back. Always. So how do I make it so that it doesn't do that?
2f.
2f. One of them needs to be a float. Both of them could be floats, that works too, but really only one of them needs to. And then when we do that, house average number of tenants per floor, 1 2/3. Apartment, 1.0.
Is that a Ruby thing with the float, or is that a universal property of floats and integers?
I'd say that's more common than it's not.
Okay.
Having a lot of different kinds of numbers is pretty normal. JavaScript only has 1. Integers, floats, anything, double precision floats, all of them are just numbers. Ruby, Java, C, basically everything else has a lot of different kinds of numbers. And the reason that this works the way that it does is most of the time you want things to return consistent types. So if I divide 2 integers, I either always want to return an integer or always want to return a float. This is not a thing that you're going to understand in day 5 of being a professional programmer, but that takes an entire class of problems, excuse the pun, an entire class of problems completely off your table if it's always the same data type. Cool, and that's the assessment. If you can confidently do all of those things, you know enough about classes and objects for right now. And you are full-throatedly ready to start working on relationships. So with that in mind, give me some more questions about this.
How about the Fermi estimate? How does that apply? Or
So can anybody tell me what a Fermi estimate is? Do you just know?
I looked it up earlier.
Cool, tell me, what is it?
It's basically like a super educated guess, where you take the things that you do know and figure out the most educated guess you can. Is all like the one way to sum it up, I guess. Kinda.
And there's an interesting principle behind it. Did you catch that? It's the thing that makes it super educated. There's kind of a neat math principle at work.
You overestimate with some of the variables and underestimate with the others, so it'll kind of balance out.
Exactly.
Cool.
Sorry, my trash can just overflowed. So I think that like actual spec for it is something like, if you make a bunch of guesses, but all of the ingredients are the correct order of magnitude. So by order of magnitude, we're like 0 to 10, 10 to 100, 100 to 1,000, number of decimal places, basically. If all of the things you are using to construct your guess are the correct order of magnitude, your end result will also be the correct order of magnitude. And this works shockingly well. And it's the way that you answer all those like goofy Silicon Valley interview questions, like, how many ping pong balls would fit into this room? All right, well, a ping pong ball is about 1 inch in diameter. And I would guess that this room is about 10 feet by 10 feet. So that means that I could fit this many square inches of ping pong ball in this room. So it's about that. So if you do that, given that like it's not actually 100 feet by 100 feet, and that the ping pong ball isn't actually 10 inches by 10 inches or 1/10 of an inch by 1/10 of an inch, assuming all of those are correct, whatever final result you get will also have the right number of decimal places. This also applies to things like, how many windows are there in New York City? Or another classic one is like, how many piano tuners are there in Chicago? That one ends up being kind of interesting because you make estimates of like, okay, well, how many people in Chicago have pianos? How often do they get tuned? How many pianos can somebody tune? And so like you can work backwards from there and get the correct number of piano tuners. So that one in particular, they did their research on, and like the Fermi estimate, I've done this exercise with students a bunch. Everybody ends up getting in the exact same order of magnitude, and also like very close to the real number with the like census survey of piano tuners in Chicago. So yeah, it's a way to make a really educated guess. And can you imagine why those Silicon Valley companies might value something like that? Why does Google care about Fermi estimates?
You have to scale things at different levels.
Yeah. Yeah, scale things at different levels. It helps to be able to like make some guesses at what that scale looks like, because some of these things are just physically impossible. some of these things are like, it's impossible to make money with. These Fermi estimates help us get a like ballpark estimate of what kind of scale we're talking about. And that can help us make some decisions about whether or not to even do something in the first place. Cool, so if I'm gonna make Fermi estimates, let's see, there's a giant ass apartment building across the street from me. If I'm counting, oh cool, I can count the apartments across real quick. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So it's 12 one way. It is 4 floors high and 1, 2, 3, 4, 5 apartments the other way. So 12 times 4 times 5.
40.
That's 20 times 12. What's the number?
240.
240. So I'm guessing there are 240 apartments in that building. I think on average, there's probably 2 people in each apartment. So I'm guessing there is 480 people in that building. That's a Fermi estimate. So the principle is that it might be 600, it might be 700, it might be 200, but it's not going to be 48 and it's not going to be 4,800. And I feel pretty good about that. So it's 4 floors with 480 people. Floors, yeah. That's how you do the Fermi estimate. More questions?
What doesn't your linter or editor or whatever it's called like about those 3 lines right there?
Ooh, that's a great question. Can you guess? Can anybody guess?
Could you repeat it, Ben?
Why do I have those 3 like warning signs? Why is my linter mad about how I wrote this?
Could it be because you don't have parentheses?
Nope.
Colons?
Good guess. Not that either.
Commas?
Nope. This is syntactically fine.
Oh, it probably just wants a space in between each one.
Nope, not that either.
Is it because you actually aren't calling any of those like house, apartment, old folks home in the rest of your document, so they are unnecessary?
Exactly. The program works exactly the same if I do that. Now, for like the way that we're using this, the nice thing about having those in there is that when I run the program, I already have house. I didn't need to like type all that out. But the linter doesn't know that that's what I'm planning on doing. So it just gets mad. Cool. Other questions? Ooh, this is a good opportunity for that that pretzel. Check this out. We could write that like that, or we can write it with that placard, and it works the same way. So building.placards, building.placards. So it works.
What did you just do right there?
These, this and the thing that I commented out are identical. The difference is that we call map with parentheses, not with a block. We give it the ampersand, little pretzel, and then we put the symbol for the property that we want. Because this kind of map is really common, turning an array of things, or an array of objects into an array of the results of some method on the object. That's really common. So in Ruby, there's a little shorthand for it.
So is the ampersand sort of saying like representing each building?
Correct. And saying, hey, this symbol placard, that's the name of the method I want you to call on every instance. That's a
so how can map actually locate placard? Like it's not initiated. Like how does it know to call that?
Oh, it is though. So I made this building, I made this building, I made this building. So add all has 3 buildings in it. And then it maps over each of the buildings, and in this block, building there represents first house, then apartment, then old folks home. And then for each one of them, it returns its placard method, which returns that string. And then this is another syntax for that exact same thing.
That's cool.
Wow. Okay.
But if I called building.placards here, I'm going to get an empty array back because there's nothing to iterate over. If I do it there, I'm going to get 1. If I do there, I get 2. If I do it there, I get all 3. Other questions?
Is this going to be uploaded for the weekend?
Yeah.
So placard is instance method, and it kind of just takes whatever the name and the address that's put in at every time.
Correct.
But when you call it an all map, I'm trying to figure out how does it actually just get whatever you're looking for? You know what I mean?
Sure. Because okay, so self.placards, that's a class method. Classes don't generally know about their instances. However, we've been keeping track of them with add-all. So when I map over them, I have access to specific instances, and I can call it specific instances placard method all day long. And that's exactly what I'm doing here. So again, the long version of that would be add-all.map to building. That is an actual instance of a building, and actual instances have placard methods. So I can use them there.
Okay, so in that case, can you just say add all square brackets placard, and then just go from there?
So if I did something like that.
Yeah, can you work with that?
No, because add all is an array. So if I do that, it's trying to look for an index that maps up to the symbol placard on the array. Well, I don't want to do that with the array. I want to do it with each individual thing in the array. So that's what the map lets me do.
Gotcha.
Are there
So right
other
now,
situations? Sorry.
Was that?
Are there other situations where you'd use the ampersand?
You use the ampersand anytime you're just trying to pull a single method off of an object. That's what the pretzel's good for. Okay, so that's what's in add-all right now. So if I do add-all placard, that would be like doing That doesn't do me much good. Oh, even throws an error. On this, though, that's exactly like I just took this and called the map on that directly. So it gives me access to each individual one. And then that's just a short way to do that. More questions?
Can you show how you you have the other file where you're creating the instances and how they're connected? I know it's up at the. You just require the file with that. Gotcha.
Yeah, and so Pry is a library. We downloaded that with Gem. So no dot in the front. This is just some file that I wrote. It has to start with a dot.
Go get some water.
A note on that is I was having a lot of trouble connecting those two yesterday, and it's just because I wasn't saving. So every time I saved, it would properly connect.
Yes. Gotta save. Anything else?
Is there like a built-in, maybe like VS Code feature that auto saves after something happens?
Yes.
Awesome.
It's right under file. You just check autosave.
Perfect. Thank you.
Any other questions?
I've been trying to do the placard. I've been doing building.placard, but it keeps on saying it's an undefined method, that no method error.
Okay. So placard, the way that we wrote it here, belongs to instances. It's an instance method. So I would call house.placard, apartment.placard, old folks home.placard. There is no building.placard. Here I have self.placard, so that's a class method, but plural. Could be singular, that's fine, that'll work. We'll do that. Run this, building.placard. There we go.
Sorry, that's what I meant. I meant placards. Let me try one.
But it's got to start with self. That's how we say that it belongs to building, not a building.
I figured it out. I don't know what I did, but something changed.
Beautiful. Cool. Anything else? All right. Have a good lunch. We're back at 1, I think, for relationships, if that's your jam. I'll see you then. Bye.
Thank you so much. Have a great lunch.
You too.